Hi, in this video this series of videos we're going to be working through a GCSE paper. Please do stop the video, have a go at each of the questions, then compare your solutions. Each of the videos is going to be about 20-30 minutes or so. It should give you about an hour's worth of fairly focused revision. If you're not sure about anything, always add a comment. I'll come back to you and I'll look forward to seeing you inside the video.
Hi, this is the third video in the series where we're looking at the November 2019 higher tier paper 2 for Edexcel. In the previous video we completed through to question number 18, so in this video we're going to start again from question number 19. Okay, so here we're at question number 19 where we're going to use the volume of the sphere formula we've already been given, which is 4/3 pi r cubed, and really it's just a case of using the information we've got there and just at least initially imagining that we're dealing with a complete sphere with a radius of 4.2, which is half of the diameter that's given there. So when we calculate that, we're going to get 310.3390. Okay, now don't forget it's only half a sphere that we're looking for, so therefore it's a hemisphere, and just using my calculator I would write answer over 2, and that's going to give us 155.1695. Therefore, to three significant figures, it's going to be 155 centimeters cubed, which would be the answer to that particular question. Okay, let's move on then to question D, which is a question relating to bounds. So we're told that C is 10.9 correct to three significant figures. So let's just have a look at that for a minute. So 10.9 to three significant figures means that the lower bound is going to be 10.85 and the upper bound is going to be 10.95, and then really it's just a case of using those two numbers in our formula to get an answer. So I'm going to first do the lower bound, and that's going to give me 159.6611406. Okay, and then if I do the same with the upper bound number, I'm going to get 10.95 cubed, and that's going to give me 164.1165. Now the question says, by considering bounds, work out the value of D to a suitable degree of accuracy. Well, the only value of D we can use would be 160, because that's where both of those numbers that we've got, or both of those solutions, would be correct to 2 decimal places. Okay, so that would be the answer to question number 20. If you're not sure about that, do please let me know in the comments, and I do have some other playlists that you can have a look at. Okay, let's move on then to question number 21, which is a speed time graph. It's a train journey between 2 stations and the journey took 100 seconds. Okay, right, so calculate for the time taken for the train to travel half the distance. Okay, so let's have a look firstly at working out the total distance, and then we'll calculate from there. Okay, so what I'm going to do, I know it's a trapezium and I know I could use the trapezium formula, but I'm being asked to work out time. So I think in this particular case it would be a lot easier to actually divide this up into 3 sections. So my first section is going to be a triangle. I'm going to call it A, and then I've got a rectangle, which I'm going to call B, and then I've got another triangle which I'm going to call C. So let's look at the area of each of those in turn. Okay, so the area of A is going to be the base times the height, which is, a half base times height, which is going to be a half, and the base, hopefully you'll be able to see at the top there, is going to be 30, and then the height itself is going to be, in this particular case, 12. Just be very careful when you're actually reading these particular charts. Each of the small squares, actually there's 2 squares, which will equal 1 unit. Okay, so that's going to give me then a base of 30 and a height of 12. So that's going to be 30 times 12, and that's going to give me then a total distance for section A of 180 meters. Okay, let's look at area B. And that's going to be just simply 50, which is the difference between 30 and 80. And that's going to be multiplied by 12, which is going to actually give me 600. So 50 times 12, and that's going to equal 600 meters. Okay, and then finally I've got area C, and again that's a triangle, so that's a half base times height, and that's going to be a half. And the base, hopefully you can see at the very top of the screen there, is going to be 20, and then the height again is going to be 12. I pop that into my calculator or I work it out, and that's going to give me 120. Okay, so the total distance is going to be 180 plus 600 plus 120, so the total is going to be 900 meters. Okay, now we're being asked to work out the time taken to travel halfway, which is going to equal 400 meters. Okay, well, let's have a look at the first section of our journey. The first section of our journey, I know it's going to take me 30 seconds to travel 180 meters, because what I've said is this is 180 meters and this is the time it's taken me. So therefore the time for the first 180 meters is going to be 30 seconds. So first 180 meters is going to equal a time of 30 seconds. Okay, now don't forget I've got 450 meters to go. Okay, so therefore I need to travel another last part of the journey, or the second part of the journey really, which is going to be 270 meters, because if I add those two together I'm going to get 450, and therefore the time, in order to work that calculation out, I'm going to have to use speed equals distance divided by time, because I know the distance is going to be 270 meters and I know my time is going to be 12 seconds. So therefore I've got the ability to be able to put that into the formula and work out time on it. So remember, it's time that I'm interested in, which is going to be the distance of 270 divided by the speed, which is going to be 12, so that's going to be 22.5 seconds. Okay, so therefore I've got now my two times, my first part of the journey, which is 180 meters, then my second part of the journey, which is 270 meters at 22.5, so therefore 30 plus 22.5 is going to give me a total of 52.5 seconds. Okay, and that would be the answer to part A. So a little bit tricky, quite a lot of information going on there. Again, please do let me know and I'll be able to help you in the comments. Okay, so then it says compare the acceleration of the train during the first part of the journey with the acceleration of the train during the last part. So let's have a look at the first part. Well, this is acceleration. So it's an increasing acceleration, it's a positive acceleration, and then this is a negative acceleration at the end of the journey, so we would normally call that a deceleration. So let's have a look, how would we write that? Well, we could put initially acceleration is positive to travelling speed, if you like, of 12 meters per second, and then final stage acceleration is negative, and we would call that deceleration to 0 meters per second, so which is the train stopping. Okay, and that would be the answer, and that'd be certainly good enough to get 1 mark on that particular part of the question. Okay, shall we move on then to question number 22, which is kind of it's a compound interest or a growth and decay. And again, if you go to 3-Minute Maths, there is a worksheet on this that you can have a look at. So what we're saying is at the end of March there's 200 rabbits on the farm, and then there is in this particular case actually a decay of rabbits on the farm given by the formula 1.2p to the subset n minus 50. So let's just use that information. We can say that in March p to the n is going to equal 200. Okay, and then we've got April, which is now p to the 1, which is going to equal the formula 1.2 multiplied by 200 minus 50, and that's going to be then 190 rabbits on the farm. Okay, so let's have a look at what's happening in May, which is P2. Well, that's again going to be 1.2 multiplied by 190 minus 50, and that's going to give us a population on the farm of 178. So there's actually a decline of rabbits. Okay, and then at the end of June, which is P3, there's 1.2 multiplied by 178 minus 50, and that means at the end of June we're now down to 163.6 rabbits, which we can't really have. We'll have to have 164 to round up to the nearest unit. So at the end of June there would be 164 rabbits on the farm. And then it says, considering your results in part A, suggest what will happen if the numbers of rabbits of farm after a long time. Well, after a long time the rabbit population would be 0. Okay. And if you wanted to use that formula, you could kind of work out how long it would take for the rabbit population to decline entirely. Okay, let's move on then to question number 23. So the diagram shows a parallelogram, and the area of the parallelogram is greater than 15 centimeters. Show that. And this is one of those questions where really you just need to be very careful with your expansion and working things through. So let's have a look at how we would do that. I think if it was me, because I'm used to working out an area of a triangle, what I can do is I can use a half AB sine C, and that just kind of makes my life easier if I just split this into 2, because then I can say, well, actually if I work out the area of A, I can then double it and I've got the area of the whole parallelogram. However, I'm not going to really worry about that too much. What I'm actually going to say is the area of the triangle is going to be a half AB sine C, which is going to be a half multiplied by 10 minus x multiplied by 2x minus 1 multiplied by the sine of 150. Now what we're told is that that's greater than 15 centimeters. Well, because I'm only going to do a half of it, I'm going to say that's greater than 7.5, and that just makes my life a whole lot easier. Then I don't have to start doubling everything. Okay, what I've also noticed is that sine of 150 is actually a half. So what we've got now is a half multiplied by a half, which is going to be a quarter. So I can write that out now as a quarter multiplied by, and I'm going to expand these two brackets. So I've kind of dealt with that one, I've dealt with that one, and I'm going to expand those two brackets in the middle there, and I'm going to get 20x minus 10 minus 2x squared plus x. Now I'm very aware I am rushing this or going through this fairly quickly, but if you're not sure, please do let me know, and I've got similar exercises that you can have a look at. Okay, so I need to get rid of that quarter really. So if I multiply both sides of the inequality by 4, then it means I can get rid of this first quarter here, and also I'm going to take advantage of just sorting everything out inside the brackets there. So what I'm going to get is minus 2x squared plus 21x minus 10 is greater than, and again 4 times 7.5 is going to be 30. Okay, so let's just tie that up a little bit. What I'm going to do is make my value of 2x squared positive, and I'm going to move everything over towards the right hand side. So I'm going to get 0 is greater than 2x squared minus 21x plus 40, and that's what we're being asked to show right at the very top of the screen there. So therefore I can write this the proper way round, which is left to right of 2x squared minus 21x plus 40, and that's less than 0, and that would be the answer to that particular question. So a little bit tricky. Just as a point here, this is the value of A and this is the value of B, and that's how I got that 10 minus x multiplied by 2x minus 1. Okay, let's move on then to question part B. Find the range of possible solutions. What we're basically doing is say you've got to solve 2x squared minus 21x plus 40 is less than 0. Okay, now there are a couple of methods of doing this. The way I do this is I say 2 times 40 is going to be positive 80, and I want two numbers that when I multiply them together make positive 80, and when I add them together make negative 21, and those two numbers are going to be minus 5 and minus 16, because when I multiply those two together I get plus 80, when I add them together I get minus 21. And then really it's just a case of rewriting this equation, or this inequality, as 2x squared, and I'm going to put minus 16x, and then I'm going to write minus 5x plus 40 is less than 0. Now minus 16x minus 5x is exactly the same as minus 21x. I haven't changed anything, but it does allow me then to factorize the first two parts of this particular equation. If I factorize them for 2x, I'm going to get 2x multiplied by x minus 8, and then I'm going to factorize the second two by minus 5, and guess what? I get x minus 8 again. So therefore now what I've got is common terms of x minus 8. So therefore if I multiply those x minus 8 by 2x minus 5, I've then got my solutions where I can say that x would be equal to 8 and x would be equal to 2.5, or 5 over 2. Okay, so if we just draw that onto some sort of quick sketch here, I'm going to have something like that. Not the greatest sketch in the world, but this would be 8, and this would be, in this particular case, 2.5. Okay, now the inequalities where the values are going to be less than 0, so it's actually these values below the line, that's the bit I'm interested in. So I can write therefore that x is going to be greater than 2.5 and less than 8, and those would be the range of inequalities that would, or the range of possible values of x that would solve that inequality. Okay, bit of a tricky one, quite hard to kind of work through. We've got only 2 more questions to do on this particular paper, so my proposal is to carry on to the end of the paper on this video. Okay, let's move on then to question number 24. Question 24, I must admit I found quite difficult myself. So it says square ABCD is transformed by combined transformation of a reflection of the line x equals minus 1 followed by a rotation. That's strange. Okay, so under this combined transformation, 2 vertices of the square are invariant, which basically means they come back to the same place. Now I know there are a couple of solutions with this, but it is a bit of an interesting one to have a go at. So so the first thing that we'll do is we'll reflect the shape ABCD in the line x equals minus 1, which is this mirror line along here. Okay, so if we look at point A on the original shape, it's jumped by 2 places, so it's going to jump by another 2 places. I'm going to put it there, and hopefully you'll be able to see that what I can do then is I can map all the different points that I need to my new shape, which is going to look like that. Okay, now that's part of it is fairly straightforward. The bit that's more difficult is the rotation, and you'll remember that we now have a rotation, and when we've completed our rotation, two of the points, or two of the vertices of the square, are going to be ending up in the same place. Now, the way to deal with this, I think, would be to use a piece of tracing paper, and you can have a little play around with it. And what hopefully you'll find is that, let's say for instance, if I put my center of rotation here and I rotate anti-clockwise through 90 degrees, then the point A would end up going from here back to here, and actually it would be exactly the same with the point C. So we've got C going from there to over here. So what we've done is we've rotated 90 degrees clockwise around the point -1,6, and that would give us the answer to that particular question. And what I'll do on the worksheet is that, if you would like me to, then I'll also give you some other options for it, or maybe you could print this off and have a go at this for yourself. So in answer to the question, one possible rotation would be 90 degrees anti-clockwise. Okay, that would be a rotation around point -1,6. Okay, so I would imagine that would be quite a tricky one, but a little bit of tracing paper might help. Okay, we'll move on then to the very final question, and we've got a straight line has the equation there. Now, the problem with that is almost immediately it's been given to us in a way that isn't exactly recognizable, because we do want this in the form of y equals mx plus c. Now the reason that is because it allows us then to be able to imagine the gradient and also the y-intercept. So what I'm going to do is, before I even read on, I'm just going to alter this to 2y equals -3x plus 17, and then if I divide through by 2, I get y equals -3 over 2x plus 17 over 2. Okay, if you're not sure about that, that would be -1.5x plus 8.5, and it's perfectly fine if you prefer to use decimals. Okay, so let's have a look then. It says the point A has coordinates 0, 2, straight line M is perpendicular to L, and it passes through A. So we're already getting to the point where it's just getting a little bit confusing with the actual wording there. So what I'm going to do is just take a bit of time to draw a quick sketch. And the first thing is, I've got line L, which we've just worked out has got something like that. So it's a gradient of -1.5, and it passes through this point, which is 8.5. Okay, that's the y-intercept, so that's fine. And then we've got another point A, which is coordinates 0, 2. So that's actually going to be on the y-axis as well, and it's going to be perpendicular, so it's going to cross at 90 degrees. Now it's going to be a little bit difficult to see, but hopefully what we've got here is A, and then we've also got let's call this B, which is going to be up there, and then we've got this final little bit C, and it's actually finding the equation of the line A, which is going to, the line M rather, which is going to help us a little bit. So let's just write down everything that we need. So the first thing is, we know that the line L equals y equals -3 over 2x plus 17 over 2. Okay, now the next one is the line M. Okay, now the thing about line M is it's perpendicular, and it passes through 0, 2. Okay, which is fairly straightforward. Therefore, we can just say that y is the negative reciprocal of the gradient of L, which is going to be 2 over 3x, and it's going to pass through 0, 2, so therefore that must be the y-intercept. So now I've got my equation of two of the lines, one of which is going to be this one, and the other of which is going to be this one. And then I need to find out point C. Now, at point C, both of the values of y are going to be exactly the same. So therefore, I can just say the two equations are going to be the same. So I can write that as minus 3 over 2x plus 17 over 2, which is going to be the equation of line L, which is the one right at the very top here. But that's going to be equal to 2 over 3x plus 2, and that's going to be the equation line M. And then really it's just a case of using this information to find the value of x. Well, it looks a little bit scary canary, but it's not too bad because you've got a scientific calculator and you just use the fraction keys, so it's not too bad. So if I just make it so I've got the values of x on one side and the numbers on the other, I can then work out that I've got 13 over 2 equals 13 over 6x. I divide through by 13 over 6 and I very neatly get a value of x, which is equal to 3. So therefore I can say that when x equals 3, remember that we're looking at point C here, okay, which is actually this point at the very top of the screen there. Okay, so I've got a value of x equals 3, and I could just pick and choose any of the equations I want. I'm just going to say that y must equal 2 over 3x plus 2. So therefore y must equal 2 over 3 multiplied by 3 plus 2. So again, very neatly, y equals 4. So therefore c must equal the 0.34. So now we're in a position where we've got all the information we need. This point is 3, 4. Okay, so we're being asked to find out the area of the triangle ABC. It's a little bit tricky to see actually on the little sketch at the top there, so I'm going to write it out slightly better, or draw it out slightly better, because we can just use that the area of a triangle equals a half base times height. And what effectively we've got is to say, well, we've got something like that, okay, where this is the y-axis and we've got a point here of 2, and this is also the y-axis, a point of 8.5, and we know that this length along here, which is the x-axis, is going to be a length of 3. So therefore we've got a triangle where we've got a base of 6, which is going to be this. You'll have to imagine it moved around 90 degrees anti-clockwise, but we've got a base of 6 and we've got a height of 3, so therefore I can put that directly into my formula as 6.5 multiplied by 3, and that will calculate as 9.75, and that's the answer to this particular question. So again, a little bit tricky.